Select Star from Skynet. This is code that writes code. Metacode, right? So my name is John Erdman. You can find me at PostgreSQL at thewikitribe.net. I hang out on IRC for a long time, which actually I'll take a moment to pimp the IRC channel. Probably 80% of what I know about Postgres I learned on IRC. If you hang out in that channel, you don't necessarily have to really say anything. You don't have to really ask anything. Just idle in there and watch the discussions that go by. Probably about half of the core committers for Postgres, the core team, actually spend their time in there almost all the time. Like Mr. Burkus, for instance. Aglio DB is in there all the time. Notably missing is Tom Lane. He only reads mail, but he reads all the mail. And Robert Haas. But Stephen Frost is in there a lot. Mr. Jim Nasby is there all the time. And pretty much by just sitting in there and watching, but people will come in there and actually discuss new features for Postgres and argue over implementations. Gets a little off topic sometimes, but the single most common question you hear is, I just installed Postgres and I can't connect. What's going on? Right, so it's a very worthwhile and useful resource that more people should be taking advantage of. There's maybe 300 people in there at a time, but when your system is blowing up and you need immediate help and you can't wait for Dash General to respond to you, you can go in there and actually yell at somebody who probably wrote the thing that's breaking you at the moment. Or they'll tell you how you didn't read the documentation and it's your fault. So, also responsible for this idea was Jim Nasby here in the front row. He can be reached at bluetrouble.com. He's also a Decibel in Freenode, so you can bitch at him about stuff if you want to. Next slide. So we had a problem. When I used to work at a company called Enova. And when I came on, Jim had been there for about a year, I think, maybe, a little bit. And so we had 1.5 DB people to support some 40 Rails devs. And then I came on, so we had 2. And we were known as the big pain point in the company because we didn't want these Rails people writing SQL, because if you've ever seen Rails people produce SQL, you'll know exactly why. I once actually got a patch from a kid, and I'm like, how come there's no foreign key on this column? He goes, what's a foreign key? I'm like, you fucking submitted me a patch and you don't know what a foreign key is, you asshole. And I toned it back a little bit. I hit delete for it because I was talking to him on Jabber. I'm like, okay, I'll fix it. So what we were trying to do is we actually wanted to be responsible for every piece of DDL that was produced for all the software across the entire company. And to try to do that for some 40 Rails devs who are busily hacking away, designing new features, and a company that's actually making a lot of money by doing it very wrong, it's hard to argue with. And they get really angry when you can't keep up with their demands. So Jim had this idea, which was, it was in a usable state when I got there, but we worked together to improve it to some extent, and I think made some good strides on it. Metacode is what he called it. I don't know where that word came from, but it's sort of descriptive. It's code that writes code, right? So what exactly is that? That's my next slide. Okay. So to talk about, the implementation that we actually had at Enova is what I'm going to talk about. But later I'm going to talk about we're rewriting it greenfield, sort of together. And we need people to help. So that's partially why I'm actually giving this talk. So something like this is, you're going to wonder why you would even ever do this if you have a schema with 20 tables or something like that. It's just not going to be an issue. You don't have a problem managing your objects when you have 20 tables and 3 triggers and any little web-based app or something that you as one person can keep your whole head around. It's not a problem, right? But think about when you have like 600 tables, right? Or when I worked at Rackspace, we had 1,200 tables. And I came in and I was told to, enable replication. I was like, oh, I can set up Salonia. I told the manager when I got hired the first day, I'm like, yeah, it'll take me like a week. Yeah. So it turns out they have 1,200 tables, 400 of which did not have primary keys. So it took about 6 months to slowly add those primary keys. And somebody had this bright idea of using inheritance because, ooh, look, shiny inheritance. And they had inheritance on probably about half of their tables. They were inheriting a table that had 2 columns, 1 primary key and 1 like description. So that as soon as when I added a simple, oh, this is easy, let's just add a serial column to everything, right? Yeah, except it pops up like sort of out of order because of the inheritance, and it promptly breaks the entire crappy Python homegrown application that they had written. So when you're talking about a schema that's very complex or very large, you need some sort of automation around managing this stuff, right? To keep track of things, and also there's a couple of other reasons why you might want it. To enforce standards, not just standards, but correct standards. You have both. You want to make sure that if you have a lot of people who are writing code against your database, who don't really understand data or are not familiar with best practices, right? You want to make sure that you are giving them a way to make modifications and write DDL that is going to be both correct and also in a standard fashion, so that every simple lookup table that you write in your database is going to match every other one, right? So that when you go to look at something, you know exactly how to access it, you know what functions are going to be there, you know what uniqueness constraints are on there, what grants, for instance, things like that. Now, in order to actually write this thing, it ends up with a pretty complex implementation, right? But you can expose it as a very simple API to the developers. For instance, we had something called a lookup table static, right? Which is just a simple lookup table. And in order to, although all the plumbing that's behind it encompassed 3 or 4 tables and a big giant function and all this recursion and find and replace and all this other crap. In order for one of our Rails guys to actually create one of these lookup tables, they'd simply select code.lookupTableStatic cars, singular and plural, and it would just go off and do it. And you could be sure that you were getting the exact same form of an object every time somebody did this. So, how did we do it? Part of what was sort of the first piece of it was a recursive find and replace function that would replace simple like tags. If any of you have ever used any kind of web frameworks like Smarty, for instance, has a template engine built in, right? It was essentially stuff like that. So we'd have like blocks of SQL code that had replaceable keywords embedded in them with just percent signs on either side, on either end, percent table name, percent. So create table, percent table name, blah, blah, blah. But in NASB fashion, it was perhaps needlessly complex in that it could recurse in itself so that you could have keywords that contained other keywords that contained other, templates that contained templates that contained templates, and it would just keep iterating upon it until it actually couldn't find anymore and spit something out, which you wouldn't initially think was useful, but oddly enough, there was a couple of places where it actually made sense. And that's also a typical NASB thing. You start to argue with them, and then you're, oh, crap, you're right.
I don't think it started that way, by the way. I think it was not originally recursive.
Yeah.
We needed to do something and said,
It was
ooh, nuts.
probably the the inheritance stuff, I think, was like about the biggest thing that we built with it. So, what's the next one? Ha! You mean the configuration compiler?
It always rescans the result and looks for more macros, and when there finally are no more macros, it's done.
Yeah, send mail. The only thing that needs a compiler to write its configuration file.
The only thing it's known for is being bundled with SendMail.
Well, that and it was the very first internet, remember, right? Responsible for all viruses that we now have. So, so here's an example of one of our templates, a simple one. This is actually our lookup table static. So create table, get your percents, schema name to put it in, the plural name, so it's like cars, and then you'd have ID, cars, PK, and then the singular car text. So you have simply just an ID and, you know, a basic description. But some of the things that you like why would you ever want to do this? There's nothing complex about a lookup table, except that when you look at all the stuff that we actually have here, slowly over time, you think about more and more things that you want to have on every lookup table, right? Like we actually made use of SQL comments, which almost nobody does, but they can be pretty convenient when you're thrown in the deep end and you have no idea what the hell this table's for, and you just do DT plus, and hey, it tells you this table stores this, 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 and this, and don't drop it. But you can even have, you know, the keywords inside the comments, or inside the comments. So actually, this is dynamic lookup table, not. Actually, I think that comment is wrong. So part of what we did is we commonly, when you wanted to create a new template, you'd start out with an existing template, you'd copy it, and then you'd make some changes, and then you'd realize that you forgot to change like half the stuff that was in there. So it's particularly the comments. But at least there is a comment on there. It's better than nothing.
Actually, no, that is dynamic because it's got.
Is it dynamic?
Yeah.
Oh, it's got getsert. I thought, see, I grabbed the wrong one. I was trying to grab the lookup table static because I knew that both of these, so we have probably 20 different templates that we used at Enova, and of varying complexity. Some as small as this one. Some would be many pages that would not fit on here. And I can't show you any of them because they all belong to Enova. So, but this one, I am reasonably certain, is actually in the implementation that we put up on PG Foundry, because this is one of the oldest ones. So I took a chance. I'm probably violating an NDA or something. I don't know. Call the cops. I don't give a shit. Throw a unique index on it. Make sure it's lower. Right? That was something that was a bug that we figured out later on. Put some grants, create a couple of accessor functions, which these actually call code getsert. These actually call other templates. Right? So you have templates that depend on other templates, that depend on other templates, and you can always end up with like a standard format for things. So part of what this also does. The idea here is you not only, so you've gotten somewhere already, right? You have a way to enable people who don't know how to write SQL to generate the objects that they want in exactly the way that you want them to look, and not forget things like comments and things like grants, things that are going to be commonly forgotten, or not forget to index both sides of a foreign key, or other little best practice type things. So that gets you, that's a big step forward right there. But you can actually go further. We also had, part of like the idea that it was Metacode, we had a table called code.objects, which actually tracked and kept track of every single one of these you create. We record the fact that you created it, and when you created it, and what template you used, and what arguments you passed in that got substituted into this template, right? So it records, all the parameters used, the template used, and the version of the template. So part of one of the things that I added after I got hired was the idea of being able to upgrade templates, right? And so originally the templates table just had a simple template. I added a couple more fields, a drop template, so when you want to get rid of stuff, It'll actually undo all the things that you did in here because now there's not, we have two functions, a grant, and a table involved in this. So when you want to get rid of it, you would actually not remember to get rid of all the various things that you've actually created, commonly the functions. And that was sort of bad. So I'm like, all right, let's create a drop template. So you basically have the reverse of this. It would drop function, and then drop table, so that you don't forget to get rid of stuff that you've done. Then we figured out, like, I think it was actually this particular object. We had the unique constraint is on lower, right? So you can't put in a mixed case car, for instance. But the lookup on the get, so for people who are actually using our lookup function, was not using lower. So you'd call get with mixed case and get nothing, and then you try to insert it, and you get an error, which it was Lawler, who promptly called me up and said, your code fucking sucks. I'm not using it. I'm writing everything myself. I'm like, just give me 5 minutes. I'll fix it. So I added also a COM for an upgrade template, right? So that introduced an version. So the templates are now versioned, right? So when we go to fix this template, we can introduce a new version of the template that has a slightly different change, right? And when you create a new object, it always uses the most recent, most current version of the template. But because you've kept track of every single object you've ever created using the old template, you can actually call an upgrade function. And the upgrade function will look and say, oh, wait, OK, this one was created with template version 1. There's template version 2 now. Let me apply that template to it. And it would take the upgrade template, which would basically, it can be anything. And in some cases, you'd have to basically blow everything away and recreate it. But in the cases of something like a dynamic lookup table where you have data that you can't get rid of, the upgrade template contains just the differences in between, right? So in this particular case, all it would do is blow away this function and recreate it using the new template for this function, and now magically everything works. And you can simply call upgrade based on, we also kept a concept of the classes of the object you were creating. Like this is a lookup table. There was, well, we had, this is a NASB thing. There were 2 levels of types. So there was like a type. Is it a table? Is it a function? Is it a, I forget what else there was, but table and function is illustrative. But then beyond that, there was like, it's a lookup table, it's a dynamic lookup table, it's a static lookup table, it's a writable view, it's a this or that or the other thing. So you could simply insert a new template, call upgrade on static lookup tables, or in this case, dynamic lookup tables. And by virtue of the fact that you've remembered every single dynamic lookup table you've ever created, it can walk through your schema, find all instances of this object that you've had, some like 200 of them, and apply the new template, and magically you've just fixed the bug that's in 200 of your tables, right? So think about that for a second. Think about how long it takes you to actually write those stupid patches and walk through this, hacking away at the catalogs, trying to figure out and remember, based on naming conventions or something, how many of these tables are actually these dynamic lookup tables, and where does this bug actually exist? Or, you fix them piecemeal as time goes by. And this way, one line of code can repair a third of your schema. That's a pretty big deal. So that one was a big one. Yeah, so I already covered that. So some of the things that we actually, to give you an idea of just the kind of stuff you can do with this. So a static lookup table or a dynamic lookup table is a good example because it's easy to understand, and it's sort of a commonly used thing that everybody does. But there's a whole lot of other stuff that you can do with this. And the more, once you have it, it becomes sort of a Swiss Army knife that you can continue to apply to other things. So this probably doesn't violate an NDA. This is simply a description of the various templates that we had. So regular lookup table. This one was a good one, a big one. We had a template that would create a table along with a trigger that would, you know, we had lots of different tables that had a status in them, right? Like loans, for instance, it's either it's in payment, it's in default, it's this or that, and you needed to actually after the fact, we come to figure out that for compliance purposes, you have to actually track the changes to the status and know exactly when did they pay it off, when did it go into default, how long was, was it in payment, how many months, that kind of thing. So every time this template would actually create just a table that would simply track the changes to a generic status column in any given table. So you could just give it the table name and the name of the column you wanted to track, and it would create a table with a single column of the same type, along with a timestamp, put a trigger on your original table that would follow along with your status IDs, right? Which, again, not that hard to do when you write it once. But then you figure out that you have like 40 of these in your 1,200 tables, and you have to do this over and over and over and over again. And rather than cutting and pasting the same patch again and again, you create the template, and you're good to go. And then when you figure out you got a bug in it, I don't remember, we did find a bug in the status ID stuff at one point. I don't remember what it was, but something that was broken. You can just ping your little upgrade function, and whoop, you just fixed it in 40 different places. And just the keeping track of the things that you've created is pretty big. And I should say that we also, by virtue of the fact that we record the parameters that were used on the original template, when you have a new template, basically you can just take those same parameters out of that table and pump them through the new template, and that's how the upgrade process works. So that's our get function. That is the second iteration of our get text, I think. Yeah, that's the get text, I think, right? Because originally, this function didn't have the idea of loose or tight, right? So Jim one day was like, when you say get on this and it doesn't return anything, it ought to return an error. And we're like, well, okay, well, let's do that. And he's like, well, wait a minute. If we just change that, it's probably going to break about 15 things. So we created a second version of the template that included two versions of the function, and the one wrapping the other one, where it would behave in the legacy fashion by default, but you could provide an extra argument to it and the two-parameter call that would, if I don't find this row, return an error, because it should have been an error all along, but we sort of think out that one. This one was pretty big. So we have all these stupid lookup tables all over the place, and Rails hates them, developers hate them, but they're good for data consistency because when you find in your loans table, you have a status code column that's just plain old text, and you have operations people who have to go in and fix stuff in the middle of the night, and they fat finger the the status of the loan, and for some reason paid suddenly has a capital P, and now your count of paid loans is off because all your reports expect it to be lowercase p. So you create a lookup table instead, right? But Rails doesn't like that. So you can actually, we had a template, this was one of the bigger ones, one of the ones that I wrote, would magically take a table, you point the template at it, and it would follow the foreign keys and look into your objects table by virtue of the fact that you remembered every single lookup table that you've made, find any instance of a lookup table that's pointing at this table, create a view to join them together using these other little get functions so that can magically just make it work, throw 3 different rules on it, make it writable, and Rails can now point to this writable view that basically joins all your lookup tables together and makes it look like the big, stupid, flat table that they had in MySQL to begin with. And you're right back to square one as far as they're concerned, but we actually have data consistency and a proper schema. I'm going to avoid the inheritance stuff. Well, I'll get to that last. How about that? So this was our regular get by ID. This was a lookup table. Oh, yeah, there's a point. So lookup tables, stupid little simple thing. You'd think there's nothing to think about with them, but when you have a 3 terabyte database, it actually can make a difference. If you know your table is only going to have like 15 values in it, why create an ID that's an int4, right? Use a small int. So our template had small ints in it, but your Rails people are never going to, even if they create something that's reasonably good, most of the time, they're probably just going to use an integer or, serial, right? So we can enforce stuff like using a small int, which was, Jim will sit there and do the math and calculate the number of bytes along with the offset and the padding and all that stuff to tell you that you've just saved, 45 gigs out of your 3 terabytes by virtue of the fact that you used a small int. That's the second version of this. Status transitions. There's the status transitions that I talked about. Well, actually, that's a different one. So this is track status changes, but this is status transitions. So we wanted to have, we had all these status tables, and now we had little lookup tables for them and writable views to make Rails happy about them. But we wanted sort of like think of it as like a mini state machine. Your status can only go from here to here to here to here to here to here. You can't go from default to, well, I can't think of a good example. But say something like time. You can only go to morning to afternoon to night. You can't go backwards, right? So this template would create a table that defined all the different statuses that were there and which ones were valid to move from one to the next. And throw a trigger on your original table that would enforce that fact, right? And the Rails people couldn't actually see any of this. They'd just get an error if they tried to do the wrong thing, which was nice, except for the fact that their code was probably broken to begin with, so as soon as you put the stuff on there, everything blows up. But that's how you keep your job. So that's our text lookup function. So we in the previous one example, we had that's get certain get. Well, we had a get and a get text. So you could get by the ID or you could get by the text. So the name of the car or the ID of the car. And that's actually surprisingly useful because when you're doing a select on a table and you don't want to bother with the join, in the column where you're selecting the ID, you can just do the get function, which was always named the name of the table, name of the schema, name of the table, underscore, underscore, get. So you always knew what it was without knowing whether, and you knew it was there without having to look for it, right? You just put that into your select list around the ID column and you get the actual text name of the car out. Okay. I don't know cards. Here's where Jim and I differ on the whole concept of this thing. Well, not exactly differ, but Jim takes it a step further, I would say. The easy way to understand this is to think about it as just SQL templates, right? These are chunks of code with replaceable tags in them that you can use to make sure that you get consistent objects created in your database every time. And you can expose this to people who are the uninitiated, right? Jim thinks of this, and the reason why we call it PG Classy, as more of a class system for databases, right? Think like object-oriented programming, right? And I think I have, here's a good example of this. So, PG Classy, well, how to describe this? This is kind of difficult. Okay, so classes, right? You have classes. Templates are actually classes, and templates themselves are the constructors for these classes that you're going to create. And they have members and methods. Actual instances of them are an existence of a particular static lookup table. That's an instance of your class of static lookup table. Cars, foo.cars. And they have types, which are class members, which I don't actually remember how that one. Jim's going to come up and disagree with me in a few minutes on all this shit. That didn't make it in? All right. So, that's sort of the grand goal for this stuff, and it's another way to think about it. But if you don't think that's worthwhile, you can sort of skip around it. However, if we do this right, it'll end up with something that is actually like this. So I skipped ahead there. Okay, so cluster templates. So the problem with this is that Enova owns all this code. So that's why I can't actually show you any of the good stuff we have. I discovered I still had a dev copy of the database, of the Enova database on my machine at home. So I actually had all the templates. And I was like, going to stick them all in my slides. And Jim's like, no, 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 no. I'm like, oh, crap. Okay, I can't do that. Because it would be more illustrative to actually find me afterwards. I'll show you some of these multi-page templates to show you the complexity of the stuff that you can actually create. Oh, for instance, we at Enova actually used inheritance for something other than partitioning, believe it or not. And it actually worked and was useful enough that I drank the Kool-Aid. Now, it was very difficult to convince anybody else that it was of any use. However, it was useful. And one of the things about inheritance that you can make the argument that inheritance is actually broken, right? Because it feels like sort of like classes, and it feels like inheritance until you actually go to use it. And then, so for instance, we had a payment instruments table, right? And that was our parent table. We had a couple of children hanging off of it. Two of the ones that are easy to understand was bank accounts and credit cards. So you could pay with either an ACH out of a bank account, or you could pay with a credit card when we gave you a loan. But there are certain things that are common to both of those things. They're not the same. There's differences between them. But there are parts that are common that when it comes time to decide whether or not your loan's been paid off, all you care about is what did the payment come in and when was it made, right? So that was the common stuff that was in the payments parent table. And things that made bank accounts and credit cards different, like a credit card number versus a routing number and an account number for a bank account, were in the children. There weren't actually ever any rows in the parent table, and we would have, as part of our massive template that created all this crap, we'd throw a trigger on there that would say, you cannot insert into the payment instruments table, only into the children. But when the app needs to know whether or not when a loan payment came in, it doesn't care if it's a credit card or a bank account, so it can just select from the payments table, right? Which is nice. And if you know anything, how many people know how inheritance works in Postgres? No, almost nobody should. Okay, it's kind of like, it's like a combination of a table and a view that's a union of all the children. So basically, you can think of it as when you select from the parent table, when you select from payment instruments, what actually gets executed is select star from payment instruments, union all, select star from credit cards, union all, select star from bank accounts. And it makes it appear as though the data is actually living in the parent table, but it doesn't. It's really in the children. And the problem with that is you have a payment instrument ID that's in both of these child tables, which is what you reference in all the tables like loans and loan payments and things like that reference any kind of payment. Yeah, so that points to the payment instruments table, not the children, and the data is not actually in the payment instruments table, it's in the children, so the foreign key doesn't work, as well as you can't enforce uniqueness across these things. So we hacked up well, it had value, but you could make an argument that it was broken and it was full of race conditions and things like that would enforce things like uniqueness across these two children. So you didn't want the same payment instrument ID in a bank account and a credit card. You wanted it to behave as though they really were part of that parent table. And so we ended up with a template that was probably about like 4 pages long that created a whole bunch of stuff and triggers to anytime something was inserted. It was basically like a poor man's foreign key that would go and look, figure out where the children were and look in all those tables to make sure that that ID actually existed. Now that's not nearly as reliable as a real foreign key, but it's a big step forward from what you get with plain old inheritance. So that was an example of one of the more complex things that we did. Now, these were, I already showed you the slide, but these were our goals for redoing it, right? The first thing that we came up with is, well, first of all, we want this again. We want to be able to use it again in our consulting company that I was formerly a part of, because it was pretty damn handy. But we couldn't use what we had at Enova because they owned it. So we decided to rewrite it, and when we sat down to think about rewriting it, I'm like, this hacky find and replace thing that we had before, which was simply a function that Jim wrote that just did a simple text replace recursively on these percent sign keywords that you'd see and stuff, was not very fast, and it was kind of limiting, and it was a severe pain in the ass to debug. Anytime you had, the problem with the old implementation was when you had once your template was working, you were golden. But trying to get it right initially was almost impossible. Because we had debug statements inside this find and replace function, and you'd end up with like 18 pages of debug output because it recursed its way through stuff, and you could not figure out what the fuck was going on. So I'm like, why would we, having seen a talk by one of the Heroku guys, where he talked about, he was extolling the virtues of V8. Really? Holy shit, I didn't think I was going to fill up the time. We're like, why use this find and replace thing when there are all these template engines out there? With V8, you can use mustache.js, which is an actual template engine for JavaScript. We were originally going to go with template arguments as an H-store. We were going to have a way to pre-process the template before we actually plugged the parameters in, so we could do some additional. I don't remember why we wanted that, but we wanted to have the template engines completely separate from the templates, so that we have the framework that tracks the parameters and the template and what version you used was completely separate from what language the template was written in and what engine was used to process it and generate the actual objects. And we wanted that, but I don't know if that got in. So, and a quick example of what you can do, this was my original proof of concept. A mustache template will look like this. You can have actual logic inside the template so that it will iterate over the column definitions instead of having to repeat stuff. And I'm going to hand it off to Jim to talk about the state of the current code. Here. Okay.
So as John was mentioning, you know, we built this thing originally. It did a great job, but it was kludgy. It was hard to work with. It was hard to maintain because it was all just piled together. It was something that just grew organically over time. So when we sat down and said, hey, let's do this again, but let's do it better, we looked at it, okay, what is it that you actually need for this thing? Well, you need a way to define a class. What is it that you want? Is it a table? Is it a function? Is it a table and a function? You need a way to store that definition, and you need a way to execute that definition with a set of parameters that you provide. Well, really what that is a template system. So Trunklet, and this exists, you can find it in GitHub. It's a templating system for Postgres. It divorces as John said, it divorces the mechanics of your templating from the language. So you can have mustache, I've created a really simple template language that's based on the format function, and it stores these templates. You don't have to, you can actually just say, here's a template, here's some parameters, go. But you can also store the templates in the system with versioning so that whatever you want to use this for, you can do it. Right. Well, you would. If you don't store it, there's a problem with the template that you can't. Right. That's currently not in the template system, and that's something we'll need to figure out is that should it be in the template system, should it not? But so that's Trunklet. It's a simple templating system. You can use it right now for anything you'd want to do templating with, whether it's Metacode. You can use this to generate emails. You can technically, if you wanted, you could use this to generate an HTML web page that you send off to the client. So the second thing that we created was this really simple language. It's really just more as an example. It's probably not the best way to do it, but you know, it was very easy to create this because it's just using the format function. And the syntax, you'll notice, looks very similar to what we had in the old system, where you've got these percent signs, and what we did is we added I and L and S. How many of you have used the format function? So the Postgres format function, right, it's sprintf essentially. And then it accepts parameters as JSON, which, by the way, there's no constraint for template languages. You can use whatever data type to define your parameters that you want. If you want to use JSON, use JSON. If you want to use HStore, use HStore. If you want to use an array of text, use an array of text. It's not hardwired for anything. So then PG Classy, the idea is that PG Classy is the component that sits on top of Trunklet and ties all these things together. And it does things like remember, oh, you instantiated this class that creates a table. Well, here's the name, the scheme, and the name of the table. So that now, if you need to do an upgrade, if you need to see what you've got in your system, here's the way that you do it. And Classy would add the support for doing things like the upgrade templates, if you need to change the version, if you need to drop. You can have templates, separate templates for unit tests. Maybe sometimes you want unit tests created. Maybe you don't want unit test stuff created in production, maybe only in development. So the idea is that Classy should be able to support an arbitrary number of templates for a class, and you can use whatever you need, whatever is applicable. So, and I'll simplify this in a minute, but if you look at the entire ecosystem, you've got Trunklet as kind of the foundation that lets you use a Trunklet language and stores your templates. Classy sits on top of that. So this is the infrastructure part. Then you say, okay, I want a class of a lookup table. I want a class of a status tracking table. These are classes that you would then instantiate. Hey, we have a lookup table for looking up cars. We have a lookup table for looking up auto manufacturers. We have a lookup table, we have a status trigger for what state is your car in. Is it totaled? Is it not? And there's two purposes for doing this. One is that by separating these things out, you've got tools that are individually useful. Trunklet exists right now. It's about 60-ish% feature complete, but you can go download it, please. Go play with it. If you've got anything that you would need templating for, have at it. Classy is very early in its development, but it's using Trunklet, so a lot of the features that it needs already exist. We just need to start bolting them together. And ultimately, the hope is that we can build a library of these different classes so that people can go, hey, you know, I need to track changes to this table. And people have solved this problem more than once, but now have a way that if you're like, oh wait, I know a better way to do it, you don't have to create all this maintenance framework and all this, where did I create this and what table is it on? No, all you need to do is understand how to write the class, how to define what this thing is doing. You can publish it, and then people just say, oh, hey, I've got this, I'll use it here, I'll use it here, I'll use it here, I'll use it here.
So like in the instance of like a lookup table, you can have the best practices you can share with everybody, and everybody gets to use it, right? So the idea is when we get the actual software completed, people will contribute templates that become part of the library that everybody can use, and improve upon, and share upon, and when somebody else publishes a new version of the template that fixes the problem with it, we can all just call it a little upgrade button.
So what we really want out of everybody that's here is ideas, thoughts, comments. Does this make sense? Are we just completely insane?